In many ways, it's a time saver for me because I can't stand 5 people miss class. I got to sit down 5 different times and reteach the same lesson 5 different times. You just watch the video, get it done. Review. You guys have seen this before. It's the Pythagorean Theorem. Okay, Pythagorean Theorem says if you're given a right triangle, we call this A, we call this B, where those two are the legs. Anybody know what we call side C? Starts with an H. Hypotenuse. We know that if you take one leg and square it and add it to the other leg squared, we get the hypotenuse squared. Now you've had that for many years. You know the Pythagorean theorem. You've done it well. I will tell you that trigonometry is basically the Pythagorean theorem on steroids. There's so many different ways of looking at the Pythagorean theorem, and it's super powerful. We're going to look at the basics of it today, along with the distance formula and the midpoint formula. It says use the Pythagorean theorem to determine the following. We want to find this length right here. I set it up. 5 squared plus 10 squared is x squared. 5 squared is 25. 10 squared is 100 equals x squared. 125 is x squared. I square root both sides at that point, and I come up with x is the square root of 125. Now, I would like you to write your answer in simplest radical form. Is there a perfect square that divides evenly into 125? There is. 25. So you have the root of 25 times 5, or the root of 5, excuse me. So you get 5 roots of 5. So I would like your answer expressed in simplest radical form. What is different about example 2? Yeah, we're given the hypotenuse. We're trying to find a leg. So now it changes. It's 6 squared plus x squared is 13 squared. What is 6 squared? What is 13 squared? 169. I subtract the 36, and I get x squared is 133. Take the square root. Is there a perfect square that divides evenly into 133? No, there's not. So it is simplified. Please try number 3 on your own. Did you come up with 56? Okay, square root of 56, that's a tough one. 56 is divisible by 4 and 14. So 4 is the perfect square that goes in. So we are left with 2 roots of 14. That's the answer. Okay. One more Pythagorean theorem problem. We go to the back side. We learn about the distance formula and midpoint formula. It says an 18-foot ladder is leaning up against a building. The bottom of the ladder is 6 feet away from the base of the wall. How far up the wall does the ladder reach? So I have the ground, and I have a building. The ladder is 18 feet in length. The bottom of the ladder is 6 feet. How far up the wall? I'll call that H for height. Does the ladder reach? Can somebody tell me the equation I set up? (36), so 6 squared, h squared. (18 squared is 324. There's my equation. Go ahead and open up Mr. Calculator. There we go. 324 minus 36 gives us that 288. So we have h squared is 288. We square root both sides. And you're looking for a perfect square divides evenly into 288. Any thoughts? Let's try and divide it by 16, see if that works. Yep, I get 18. 18 is also divisible by 9. So actually, I bet if you take 288, here's another one divided by 144. Is 144 a perfect square? Yeah, it is. Look at that. So square root of 144 and square root of 2. We got 12 roots of 2. Suppose you're talking to a construction worker and they said, how high up the building does it reach? And you said 12 roots of 2. What do you think they'd say? Exactly. So you might be asked to write it to, say, the nearest tenth or hundredth. So if you just take 12 times the root of 2, you come up with 16.97 feet. So be ready to give the answer rounded to the nearest hundredth if need be. But there you go. Those two answers should be able to do. Flip it over. There's something that we get from the Pythagorean theorem, and that's called the distance formula. The distance formula works like this. I want to find the distance between A and B. And what I'm going to do is I am going to make a right triangle. Can somebody tell me what this length is here? It's 4. If you notice, I go from 2 over to negative 2. 2 minus negative 2 is 4. And so this length is 4. Can somebody tell me this length right here? 5. I go from 2 down to negative 3, and 2 minus negative 3 is 5. So that length is 5. That's enough information to be able to find the distance between the 2 points, isn't it? Here is the formula that we use. Distance is equal to the square root of, and I'll give this to you on the test. You don't have to memorize the formula, but it's simply the Pythagorean theorem. Look, to get 4, we subtracted the x values. x1 minus x2. And in the Pythagorean theorem, you square that side. You add that to, what did we do with our y values? We subtracted them. y1 minus y2. And we squared that. And notice, every time you do the Pythagorean theorem, you end up taking the square root of the result. The distance formula is the same thing as the Pythagorean theorem. I know they look different, but they're really just the same. So we are going to start by finding the distance. We'll do the midpoint in a second, but we're going to find the distance between these two. And we're not going to use the coordinate. We're simply just going to use the Pythagorean theorem. So I'm going to make a triangle, just like so. What's the length of this side? 4, and the length of this side is 6. So I want to find that distance. 4 squared plus 6 squared is d squared. So 16 plus 36 is d squared, or 52 is d squared. Does anybody know a perfect square that divides evenly into 52? 4. 4 goes in how many times? 13. So we have 2 roots of 13. You do number 6 on your own. Okay, for the next one, come up with the root of 73. You can't simplify that. Okay, so we move on to this piece. And by the way, for those of you maybe kind of wondering about the mic, when Mr. Moyer has been answering the questions, you can't hear him. You know what I mean? So like if, you know, Colby, call me an idiot. Okay, you won't be able to hear that. So if you watch a video back tonight, you won't be able to hear that at all. Okay, but if I say, Colby, you're an idiot, now the whole world knows about Colby. Oh, you interesting. Now, if you want to come up and wrestle the mic out of my hand. No, okay. All right. Oh, wow. Man. Remember the days where Moyer wasn't here? He was getting surgery on his hand. No, they were sad. They were sad. Carson cried. Not that Carson, this Carson. Jeez. All right. Along with the distance formula, there's another formula that we need to know. Okay, I'm going to give you a situation. Okay, Mia, she scores 4 goals in 1 game. What position do you play? Center. Okay, so you could score 4 goals, right? What's the most you've had in 1 game? 2. All right, another game she scores 2. What's her average? Her average is 3 goals a game, right? You just add them up and divide by 2. That's how the midpoint formula works. Suppose you have the coordinate x1, y1, and suppose you have the coordinate x2, y2. There is a midpoint that we can produce, and we simply go like this. It's a coordinate. How do you find the x value of the coordinate? You add the x values and divide by 2. What do you think we do for the y values? You add the y values and divide by 2. Now, we're not going to find the midpoints for number 5 and 6, but we are for 7 and 8. So our last problems for the day, we're going to find the distance and midpoint by simply looking at these, okay? And I'm going to start by using the midpoint because that's the easiest one. Midpoint. So as we set this up, I just want to be clear, okay? Bradley, you tell me. I'm going to move my marker from here to here. You tell me when you think I'm at the middle of the segment, okay? You tell me. Okay, yeah, I would say that's a good approximation, okay? That's the spot we're finding for these coordinates. How do I do it? What are my 2x values? I take 3 and -1, and I add them together and divide by 2. My y values are -2 and -3. So -2 plus -3, and I divide by 2. 3 plus -1 is 2. 2 divided by 2 is 1. -2 plus -3 is -5. Divided by 2 is -2.5. Straightforward? Okay, the second thing we're going to do is we're going to find the distance. And when we find the distance, we set up our formula. Distance equals the square root of x sub 1 minus x sub 2 quantity squared plus y sub 1 minus y sub 2 quantity squared. What do you plug in for x1? 3. What do you plug in for x2? -1. What do you plug in for y1? -2. What do you plug in for y2? -3. Lots of order of operations here. What do we do first? What's 3 minus -1? 4 squared. 16 plus, what's -2 minus -3? Add the opposite. -2 plus 3, 1 squared. 1. What's 16 plus 1? So the distance is the square root of 17. So you're going to have to be able to find the midpoint and the distance, and then use the Pythagorean theorem. We do one more together. Midpoint. Okay, I just showed you how to do it. Now you lead me through it. What do I do? x2 minus x1 close. Plus, remember, midpoint is the average, so we add them together, right? So we add them. 2 plus 4, then what? Over 2. Now what? -7 plus 4 over 2. Good. So we've got 6 over 2 is 3. And -7 plus 4 is -3 over 2. -1.5. That's a midpoint. Yeah, if you leave it as -3/2, it's absolutely fine. Now I got to find the distance. I'm going to set it up with you, and then you're going to try to make sure you can simplify it on your own. Distance is the square root of what? What do I plug in? 2 minus 4. Good. The x's subtracted. Then good. See if you can simplify it from there. Go. Okay, did you guys get 4? Did you get 121? 4 and 121 make 125. 5 roots 5. Now, folks, I want to be clear because this is a common mistake, and you guys made it a lot on your last test. When you did the Pythagorean theorem, -b plus minus square root of b squared minus 4ac all over 2a, okay, that was a really good time. But when you guys took, say, -6 and squared it, if you take a negative number and square it, that means a -6 times a -6, right? That's a positive 36. You don't ever square a negative number and come up with a negative number. Maybe you're typing in your calculator incorrectly. Watch, if I type in, clear, -6 squared, I get -36. If you type in a negative number to your calculator, you got to put parentheses around the negative. It's got to square the negative as well. So I want to be clear. These numbers here, when you square those out, they can never be negative. If you did, you made a mistake. Okay? All right, what's your assignment? Right here, front page. So you're going to rip that off, and that's what you're going to turn in on the day before a test. The other sheet are your notes. Oh, wow.